Okay, so during the last video, we covered 4 problem-solving methods. We covered trial and error, guess, check, and revise, draw a picture, and using algebra. So the trial and error was just literally making a guess and seeing if it works. Guess, check, and revise is making a guess, thinking about it, how you could change it to get the correct answer. Drawing a picture was drawing a picture to figure out the answer, and using algebra. So students, depending on their age level, lots of them like to draw a picture or use trial and error, or maybe a combination of trial and error and guess, check, and revise. But they really like to draw a picture of it, just because lots of kids are very visual, and that's fine. Sometimes it's not efficient, but that's a great method. So today we're going to talk about looking for a pattern, solving a simpler problem, working backwards, making a list, using arithmetic, and using a tree diagram. So these are other strategies you can use to solve problems. So the first thing I want to talk about is that math concepts can be represented in many different ways. And so we kind of already saw that. There's 4 different ways to solve this problem, the strategy, but it can be presented as a picture or as a table or even as a graph or in words or an equation. So you can understand a math problem much better and at a much deeper level if you can see it all the different ways. So that's why we're going over all these different strategies, so that you can have a better understanding of problems. And so that's another reason, like you'll see throughout this course, when we go over addition, I don't just show you one way to do it. I'll probably show you, 5 or 6 different ways to teach addition in your classroom, and that just makes you a better teacher that understands the problem better, because there's no one wrong way to do it, or there's no one right way to do it. There's many different ways to do it. Some might be better than others, but there's multiple different ways to do that, and we want to encourage that problem solving in our students. So I have 5 problems here that we're going to use these new methods with, and I will attach this if you would like to have this copy. This handout, you can print it off and use this for your notes. So you might want to pause and go print this off if you would like to, or you can just write it or refer back to it. It doesn't matter. So the first problem is the average score problem. Okay, so it says the average score of your 6 exams is 77. What do you need to make on the last exam if you want a B in the class? So the first thing we need to know, so understanding the problem. To understand this problem, we need to talk about what average score means. What does average score mean? Okay, so an average is the sum divided by the total number. So for example, if we had 6 students that had, 6 different ages, if we wanted to figure out their average age, we would add up their ages and divide by the total number of students we had. So that would be 6. Okay? So for this problem, there's lots of different ways to do this. Okay? So average score of your 6 exams is 77. So one way you can think about it in points, or you could think about it like as an equation to solve for a grade. Okay, so I'm going to do it both ways. And if you have a different way of doing it, more than likely, if you get the same answer, obviously it's the right way. There's not only 2 ways to do it. I'm just going to show you these 2 ways. Okay, so let's think about it in points. Okay, so 6 exams so far, and the average is 77. And we want an overall average of a B. So thinking through the problem, an overall average of a B would be like an 80, right? A B is an 80 or higher. So we're just going to talk about an 80, because if you get an 80, that's the lowest you can get and still make a B. Okay, so the points I have so far. So the points I have so far in the class. I've taken 6 exams, right? 6 exams, and the average is 77. So I can pretend like I made a 77 on all 6 exams. You more than likely didn't, but that's what an average is. It means that I could pretend like I just made the same grade on all of them, and it all comes out the same. Okay, so 6 exams times 77 gives me a total of 462 points. Okay, so let's think about the number of points I need in the class. Okay, so the points that I need to make a B in the class, I have to have an 80, right? I've taken 6 exams. I have 1 more exam. Okay, so the points I need it to be 7 exams times 80 points. And 7 times 80 is 560 points. Okay, so to figure out what I need to make on that last exam, I'm going to do the points I need subtracted by the points that I have. Okay, so 560, let's start over. 560 points is what I need. Take away what I have, 462 points, gives me 98 points. So that tells me I have to make a 98 on my test to be able to have my total of 560 points so I can make an 80 in the class. Okay, so my answer would be I need a 98 on exam 7 to make a B. Okay, so that's the points way to think about it. Some of your classes might be based on a point scale. Like, I need 560 points in the class. I only have 462 points, and that's the way you do points. The other is kind of more based on an average and like a formula, so let's do it the other way with a formula. Okay, so my total average in the class. Okay, so my total average in the class. How many exams are there in the class? There are 7 total exams, right? So my average would be the sum of 7 exams divided by how many exams are there? There are 7 exams, and I need that to equal a B. So we're going to put 80. It could be higher, but 80 is the lowest I need to make to be able to have a B in the class. Okay, so the sum of my 7 exams. Do I know what I made on each exam? No, but I know that on the first 6, my average score is 77. So I could add up 77 6 times. Okay, so first exam I made a 77. Second exam, 77. Third, fourth, fifth, sixth. So there's 6 exams that I made a 77 plus my last exam. Do I know what I made on my last exam? No. So let's put a letter in there for that. I'm going to put X because I don't know what I made. Divided by 7 equals 80. So this is all numbers in here now with 1 letter, so I can solve for that letter. So I'm going to add up 77 6 times. 77 times 6 is 462 plus X divided by 7 equals 80. To solve for X, I need to get the 7 off the bottom. It's being divided by 7, so I'm going to multiply both sides by 7. And I get, these two like undo each other. So 462 plus X equals 80 times 7 is 560. So now, to solve for X, I'm out of room on my paper here. I'm going to subtract 462 from both sides. So those two undo each other, and I end up with X equals 560 minus 462. Notice, those are points, right? Same thing we did before. Equals a 98. So my answer, again, is the same thing. I need to make a 98 on my exam to make a B in the class. So 2 different ways to do that problem. And those method that we did there, that was using arithmetic was the first one, and algebra was the second one. Okay. So for number 2, the handshake problem. There are 10 people in the room. If each person will shake hands with every other person in the room one time and only one time, how many total handshakes will there be? Okay, so what we could do is get 10 people and work it out, right? Have 10 people. If you were in the classroom right now, I would have 10 people come up to the room and start counting and doing it that way. And you would quickly see that it's going to take a long time for the first person to shake everybody's hand, and second person to shake everybody's hand, and third person, so on and so forth. So a strategy we could use for this would be to solve a simpler problem. So instead of doing 10 people, let's just think about 4 people and see if we can then find a pattern in there. Okay, so we are going to solve a simpler problem here. Okay, so our simple problem, let's do 4 people. So we're going to do handshakes for 4 people. Okay, so let's think about the problem. Make sure we understand it. 10 people are shaking hands. Each person, or for this one, sorry, for a simpler problem, 4 people are shaking hands, and they're only shaking hands with every person in the room, but only one time. Okay, so let's name these people. Or I'm going to say A, B, C, and D. Those are my 4 people. Okay, so let's think about what happens in this situation. So person A, he needs to shake hands with B, C, and D. He's not shaking hands with himself, right? Only with person B, person C, person D. So how many handshakes did person A just do? He did 3 handshakes. So we're going to say these are the handshakes. So now let's talk about person B. So person B right here, I'm going to do this with green this time. Does he need to shake person A's hand? No, because he already did. A shook B, so that means B also shook A's hand. So he does not need to shake A's hand. Instead, he needs to shake C's hand and D's hand. So how many handshakes did B just have? B had 2 handshakes. So far, A and B have shaken everybody's hand, and 3 plus 2, 5 handshakes have occurred. Okay, so now for person C. Does he need to shake A's hand? No, because he already did. Does he need to shake B's hand? No, because he already did. Does he need to shake C's hand? No, because he's himself. He only has to shake D's hand. So person C only has 1 handshake. And then what about person D? D's already shaken everybody's hand at this point. He doesn't need to shake anybody's hand. So D would be 0. So 3 plus 2 plus 1 plus 0 would be 6 total handshakes. So that was a simpler problem. It's a D. Okay, so can I use that pattern to now do a bigger problem? Sure, that's an easy pattern. 3, 2, 1, 0. Okay, so for 10 people, so this is for 10 people, handshakes for 10 people. You could put your letters up if you wanted to, A, B, C, D, all the way up to however many 10 letters would be. Or person A, if there were 4 people, they only shook 3 hands. So the first person would be how many handshakes? 9 handshakes, because they don't shake their own hand. The next person would be 8 handshakes. The next person would be 7. The next person would be 6. The next person would be 5, 4, 3, 2, 1, 0. And notice this is like person number 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 people there. And my sum is going to be my answer. So you could type in your calculator 9 plus 8 plus 7 plus 6 plus 5, blah, 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 so on and so forth. Or let's take a second and see if we can figure out a simpler way to combine those. Okay, so one common strategy, we'll get into this later, we're actually not even there yet, but is to make 10, and that's what I would say the majority of people do when they have to add something like this in their head. Instead of doing 9 plus 8 is 17, 17 plus 7 is 24, so on and so forth, it's easier to combine numbers that make 10. So I can add 9 and 1, and that makes 10, right? I can also add 8 and 2, and that makes 10. So far I have 20 with those 4 numbers. I can also add 7 and 3, and that makes 10. And then I can add 6 and 4, and that makes 10. So I've used all the numbers except for 5 and 0, and I have 10, 20, 30, 40. So 40 plus 5 plus 0 would give me 45 total handshakes. And that is your answer for the problem. So that was an example of solving a simpler problem to be able to solve a more difficult problem. The next problem we are going to do is number 3. What are the possible combinations to make 20 cents using dimes, nickels, and pennies? And so the method we're going to use for this one, we are going to make a list, or you could also make a table if you wanted to. Okay, so make a list for this problem. We'll also do make a table, but we'll do the list first. Okay, so make a list. So first thing you have to understand is the problem. If we're making 20 cents using dimes, nickels, and pennies, what's one thing the students need to know? They need to know that a dime is worth how much? 10 cents. A nickel is worth 5 cents. And a penny is worth 1 cent. Okay, so to make 20 cents, one way I could do 20 pennies, right? 20 pennies makes 20 cents. Okay, so then I could do, sorry, that's supposed to be number 2. I could do 15 pennies and 1 nickel. Because 15 pennies is 15 cents, 1 nickel is 5 cents, 15 plus 5 is 20. I could also do 10 pennies and 2 nickels. Okay, so another way I could make this almost the same combination with 10 pennies, instead of doing 2 nickels, what could I do instead? I could do 1 dime. So those are all the combinations so far with 20 pennies, 15 pennies, 10 pennies. So now, let's move on to 5 pennies. With 5 pennies, I could do 15 cents left. I could make 15 cents with 3 nickels. I could also make 15 cents with 1 dime and 1 nickel. And that's every combination with 5 pennies. So now 0 pennies, if I'm just doing nickels or dimes or alone. So 0 pennies would be, I could do 4 nickels. I could do 1 dime and 2 nickels, or I could do 2 dimes. Okay, it didn't have to be in that order. That's just kind of what I was thinking through. Starting with 20 pennies, ending up with 0 pennies. So how many combinations do I have here? 9 combinations. Okay, so making a table is the same thing. It's just, I think it's a little less writing sometimes. So I'm going to say this is my penny column, this is my nickel column, this is my dime column. So I could make 20 cents with 20 pennies. I could also make it with 15 pennies and 1 nickel. So none, none, none. I could also do 10 pennies, 2 nickels, 0 dimes. I'm just basically copying this over to a table. I could also do 10 pennies, no nickels, 1 dime. 5 pennies, sorry, I'm right here. 5 pennies, 3 nickels, 0 dimes. 5 pennies, 1 nickel, 1 dime. 4 nickels. I'm running a little bigger over here. 1 dime, 2 nickels. And then also I could do 2 dimes with nothing over here. So this is the same thing. It's just 2 different ways of kind of looking, a list and a table. So however you wanted to do that. The answer is 9 combinations either way. Okay, for problem number 4, the apple problem. John has 3 apples now. 2 days ago, he picked a basket of apples and gave away half. Yesterday, he gave away another half of what he had left, and then he ate 2 of them. How many apples did he originally pick? So if a problem tells you what they have now and asks for the original amount, this would be a problem we would want to work backwards on because it's given to us backwards, basically. Okay, so for this problem, we are going to work backwards. Okay, so start off with today. Today, how many apples does John have? John has 3 apples. Okay, so I got that information out of the problem right here. 2 days ago, he did this. Yesterday, he did this. So if we're working backwards and we're starting with today, we need to do yesterday next. And then the last thing we'll do is 2 days ago. Okay, so yesterday he gave away half of what he had left and then ate 2. Okay, so gave away half, then ate 2. Okay, so if we're working backwards, we need to work backwards this way. We need to show eating 2 and then giving away half. Okay, so he starts off with 3 apples, because that was today. Like he ended this day with 3. So 3 apples. He ate 2. So if he ate 2, that means I need to put 2 back in. So put 2 apples back in. And now he has 5 apples. This was because he ate 2 of them. Okay, so then when he gave away half, he ended up with 5. So to undo the giving away half, I need to multiply by 2. Okay, so I end up with 10 apples. So this is the giveaway half part. So he started yesterday with 10 apples. He ended yesterday with 3. And we could check our math. If we started with 10, if you give away half, you have 5. If you eat 2, you then have 3. Okay, so far we're doing good. Okay, so now let's move on to 2 days ago. Okay, so the problem says 2 days ago he gave away another half of what he had. Nope, that was yesterday, sorry. 2 days ago he picked a basket of apples and gave away half. So the only action he did here was gave away half. Okay, so if I started yesterday with 10, that means 2 days ago I ended with 10 apples. The way I undo giving away half of them is multiplying by 2. So that means John started off with 20 apples. Okay. With all this, you could draw pictures if you wanted to. You could draw 3 apples here, add 2 to it to show 5. 5, double it, get 10, so on and so forth. But we can check our work, make sure our solution's a correct solution. So, started off with 20. 2 days ago, he gave away half, so half of 20 is 10. Yesterday, he gave away another half. Half of 10 is 5. Then ate 2. 5 minus 2 is 3. John has 3 apples now, so that's correct. And our last problem for this week is the outfit problem. Okay, so Amy has 4 sweaters, 3 pairs of pants, and 2 pairs of shoes. How many outfits can she form? Okay, so for this one, we're going to use a tree diagram for this. So a tree diagram. Okay, so she has 4 sweaters. to choose from. So for the 4 sweaters, let's pick something to represent the 4 sweaters. I'm going to pick numbers. I'm going to pick sweater number 1, sweater number 2, sweater number 3, sweater number 4. For her pants, it says she has 3 pairs of pants. I'm going to pick letters. A, B, C. So capital A, capital B, capital C. And then it says she has 2 pairs of shoes. So for the shoes, I'm going to do Roman numerals. So 1 and 2, like that. Okay, so how many combinations can we come up here? So, sweater. I have 4 options here, right? I have option number 1, option number 2, option number 3, and option number 4. Okay, so for the sweaters, I have 4 options. For pants, I have 3 options with each sweater. So I could wear sweater number 1 and pants A, or I could wear sweater number 1 and pants B, or sweater number 1 and pants C. So right there is 3 different outfits. I can do the same thing with sweater number 2. A, B, C. I can do the same thing with sweater number 3. A, B, C. And the same thing with sweater number 4. A, B, C. So far I have 3, 6, 9, 12 options. Okay, that's just sweater and pants though. That's not even talking about shoes. So now let's talk about some shoes. If I'm wearing sweater number 1 with pants A, I have 2 choices of shoes. I can wear shoes number 1 or shoes number 2. So right there is 1, 2 outfits. Sweater 1, pants A, shoes 1. Sweater 1, pants A, shoes 2. Same thing with B. Same thing with C. So 1, 2, 1, 2. And same thing all the way down here. It takes a little while to write all this out. Same thing. So once you have it all written out, how many outfits does she have? So I have outfit number 1. No, I'm not going to write it. Outfit number 1, outfit number 2, outfit number 3, outfit number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So my answer is I have 24 outfits. Okay. So that is the end of the lectures for the week. So your homework assignments, these are all in Module 1. You have an introduction assignment. You have a homework for week 1 assignment. And then you have a reflection assignment. And the reflection assignment, it's a short article to read about growth mindset versus fixed mindset, and then talking about like your math journey so far and kind of where you're at with your mindset. And if you have any questions, you're more than welcome to email me, to call me, to text me, however you need to get a hold of me. I would be more than happy to answer your questions.